Isn't it strange that some of us chooses to live in a country like this, a country that's frozen solid for several months of the year, and then there's this, the white stuff covering the ground. Water evaporates, rises into the sky where it cools down, and then it falls back to the earth again, not in the same form, but as crystallized rain, also known as snow. Roads become slippery and socks become wet. For this reason, we have a tradition here in Norway. We move the snow from places where it doesn't belong to places where it doesn't belong a little less. And it's a real struggle, having to deal with all this snow. But luckily for me, I have had this friend helping me out. I mean the snowblower, the Honda. I've used this snowblower a lot, for far more hours than I can count. But thankfully it has an hour meter, so I don't really have to count it myself. So what does the hour meter say? Yeah, about 27.4 hours. That's how long I have spent running this snowblower. And for that very reason, I started thinking, how can I save time on snow removal? That's simple. I build a remote-controlled snowplow. Just a very simple machine, built from nothing and with zero experience. And this machine made snowplowing much easier. I have saved an insane amount of time by building this machine. But still, there is room for improvement. Because now I still have to go outside to plow the snow. Not only is it far away, it's also outdoors, where it is snowy and where the remote control quickly becomes freezing. And I don't want my fingers getting frostbite by plowing snow. So as you understand, it's a big room for improvement. So in this video, I'll show you how I save even more time and improve my health, simply by upgrading the snowplow to now be able to control it through FPV, first person view. By simply mounting a small camera on the front of the machine, I can transmit a wireless video signal from the freezing outdoors straight into my warm and cozy living room, without burning any calories, getting wet socks or risking frostbite on my hands. Maybe a little bit too big. I thought so too. I considered getting a smaller camera system, but then I quickly came up with another idea. I already own a couple of these DJI drones, and they have fantastic cameras, and not the least a very stable video transmission. Another advantage of these drones is that the controller have a USB-C connection. Yeah, that's great for charging, but that was not my point. By using a USB-C to HDMI cable, I can connect the controller directly to the TV inside my living room. And by doing it this way, I get a stable, high-quality video transmission system without buying anything new. I'm actually quite proud of coming up with that solution. I mean, not buying anything new. Let's do it. First step. Make a mount for the drone. At first I considered just tying it on with some rope or a piece of tape. But to save even more time, I decided to use my latest gadget, a Revopoint MetroY Pro 3D scanner. So with this scanner I can create an exact 3D model of the drone, down to a 0.02mm precision. Then I can quickly design a custom fit bracket in Fusion 360, which I then can easily print out on a 3D printer. So this scanner, the Pro version, comes with quite a lot of equipment. Of course the 3D scanner itself, but also a rotating turntable, a high quality metal telescopic tripod, and even a handle with an internal rechargeable battery. That way you can scan completely wirelessly, without using the cable between the scanner and the PC or Mac. Yeah. So the first step was to convert this physical drone into a virtual drone. The drone, a DJI Mini 5 Pro, has a fairly complex design, and modeling it from scratch would have been difficult. I decided to simplify the 3D scanning process by using the automatic rotating turntable. And since the model, in this case the drone, is a bit tall, it's recommended to use the separate tracking markers. And these markers needs to be quite visible when the turntable is rotating. So ideally the marker should be a bit taller than the model, and also placed with a bit of distance from the model itself. And therefore I designed and printed this. A round pizza tray and some marker things. Then I placed the reflective markers on the things and yeah, on the pizza board. And the whole process took about 3 or 4 minutes, give or take. And just as I finished adding the markers, this print was also done. It's a ring made of plastic. And just like that, now the turntable can handle even larger objects while still maintaining the high precision. I know that Revopoint also sells larger turntables, but this solution can be made in just a few minutes. So next up is to position the drone and all the things in a sensible way. Then I connect the battery handle to the 3D scanner and yeah, start scanning. And I must say it's quite fascinating to see how quickly and detailed the 3D model appears on the screen. And it's also so easy to do that even I can do it. So about 3 minutes later, for release time, I had a solid scan from the underside of the drone. So this software basically holds my hand during the process. I simply press the one-click edit, which performs a fusion and meshing automatically. And next I use the isolation tool, and this tool helps detect noise or elements that aren't supposed to be there. And then I could easily select what I wanted to keep and what I wanted to remove from the scan. I found that it was easier to select and remove everything from the top first and then clean up the sides afterward. So now, after the underside of the drone is scanned, I flip the drone the right way up and perform a similar scan of the top side. And once that's done, I do something I think is really cool. I press the button called Merge. And here I select both scans, and the software automatically figures out how to align and combine them into one complete model, just like the real thing. And after another pass with the one-click tool, I can fix imperfections or missing details in the scan. Like for instance this function. The software detects all the holes in the model, and just by clicking the mouse I can fill all the holes automatically. And just like that, the mesh file is finished. And I am one step closer to clearing my driveway of snow by using a remote control from my sofa inside the house. So let's print this thing. So what printer should I use? Maybe this one. Yeah, it's large. So this big box was sent to me from Prusa themselves. So inside the box it's a new box. And this is completely new. I mean, for me, testing a printer from Prusa. But the printer, the Prusa Core One L, it's also new. And it's a quite serious printer. It has a large build volume, 30 by 30 by 33 centimeters. Nice. Which of course means it can print relatively large parts. And this machine is fully enclosed. And it has an actively heated chamber, so it stays warm and stable inside the chamber, even when the weather outside is doing Norwegian things. Another nice thing with this exact model is that it comes almost fully assembled. So it seems to be 3 screws locking the print bed in place. So instead of spending 2 days of building a printer, like so, I can do other things. So this was the things that came with the machine. So it's a little camera for putting up in the corner inside the print cabinet. I guess it's some grease for the lead screws there. A 3D printing handbook, a little USB stick, an extra 0.4mm horn nozzle, of course the power cable, some tools, screwdriver, pliers, a large print sheet, and at last, probably the most important reason for everyone buying a Prusa printer, this one. So as you see, this is a quite large machine, and just to illustrate it, this is the Core One L, like so, and here you have the print plate for the Core One, the normal one. And this is the print sheet for the Bamboo Lab H2S, and this one, Core One L. Yeah. So it's a large machine, this one, but still not as large as the H2S. And finally, the setup process of this printer might have been the easiest I've ever done. I removed 3 screws, connected it to the Wi-Fi by simply placing my phone against the sensor on the backside. And just like that, we were up and running. And it's no slacker, this one. With CoreXY motion and a high flow hot end, this thing happily runs a couple of 100mm per second, with travel moves even faster, and all while still making clean and quality prints. And then we were finally there. The only thing left now, before we can save a massive amount of time with remote controlled FPV Snowplowing, is some final touches. I designed it with around 0mm of tolerance. So it's not exactly surprising that I have to trim the edges a little. And once I have a perfect fit, The next step is to install some brass, I don't know, threads, so that I can fasten these 20mm magnets. These threaded inserts are simply melted into the plastic using a soldering iron, and this is very easy to mess up. And then it was just to insert the magnets, a perfect fit, before adding some screws. After a quick trip to my daughter's hair tie drawer, I am very close to the finish line.
Production.